have a full day ahead of us today, and we're really excited to welcome you all to this year's version of Viz in Practice. So we have a great program for you today. The first two sessions that are taking place this morning will be entirely virtual, with the panelists and moderators joining you from wherever we are in the world. After lunch, we're going to be having our in-person sessions. So the morning sessions will be talking about the diversity of different ideas in visualization and practice. And following the coffee break, we're going to have a panel on visualization and accessibility. Following the lunch break, we're going to have a talk from several folks about bridging academia, industry, and government. And then our final session of the day is integrating research and products. If you are new to Viz in Practice, the way this works is we've been fortunate to have a number of individuals who are practitioners or representatives from different kinds of research communities join us today. They're going to be taking some time initially to tell us a little bit about their work and what they do. And once everybody has finished presenting, we are now going to open it up to questions from the audience. And so this is meant to be fairly interactive, and we're really excited to hear what questions you have for the panelists across the day. Now, seeing that this is the very first hybrid conference that we are having at Viz in Practice, as well as Viz, question answering and question posing is going to be a little bit different this year. So there are two primary mechanisms for asking questions this year. So one is that there are going to be participants that are both online as well as participants that are in the room in Oklahoma City. And so we'd like to try to balance the people being able to ask questions either in person or online. For people that are in the room, as aren't saying that you now have microphones today, please feel free to go up and use the microphones if that works for you and if it seems good and natural. For folks that are online, we have the Slido platform. If you're looking at it virtually, you can ask a question. Just make sure that the room that you're asking a question in is Oklahoma Station 1, which is where we are, and then we'll be able to see those questions as they arrive. We encourage both in-person as well as virtual virtual questions to be posed via Slido. It helps us to curate the questions and gives everybody an opportunity to participate. However, for folks that are in person, what we're trying to do in balancing the in-person as well as online questions is just to calibrate how many we take from each before switching off between the two platforms. Okay. And so without further ado, we're going to turn it over to our first session of the day on diversity of ideas in visualization and practice. And I will now turn it over to my colleague Svansu, who will introduce his panelists, and we'll go ahead and get started.
Thank you, Anna. I appreciate all your help, and then also Chris, who's monitoring the live in-person room for all of us. We're just going to get started. I will be introducing speakers as they're going to be presenting. And so a short bio. Our first speaker is Dr. Alireza Tehari. He's an assistant professor of mechanical engineering with an emphasis on social and cognitive robotics at Sharif University of Technology, Tehran, Iran. His research focuses on designing using social and cognitive robotics, virtual reality systems. He works with the special needs, children with autism, children with hearing problems, children with dyslexia. His research includes robots design and fabrication, serious game design, artificial intelligence and control, conducting educational clinical interventions for children, developing cognitive architectures for social robotics, mathematical modeling of participants' behavior during HRI, and empowering robots to analyze users' behaviors automatically and then react adaptively. Dr. Alireza Tehari is going to be our first speaker on diversity of ideas. Please go ahead, Doctor.
Hi, everyone. Can you hear me right now?
Yes, we can.
Thank you very much. And do you have my presentation right now?
Yes, sir, we do.
Thank you very much. Hi, everyone. Thank you very much for inviting me to this panel. My name is Ali Reza Taheri. I'm an assistant professor at Sharif University of Technology in Iran and the head of the Social and Cognitive Robotics Lab. You can see our research group, some of our students, our colleagues, and also our robots. Our research focus on designing and using social robots and virtual reality systems for education and rehabilitation of children with special needs, such as children with autism, children with hearing problems, children with dyslexia, children with CP, and so on. In this short presentation, I would like to show you some of our recent works in the field of social robotics and virtual reality systems. You can see some of our design social robots at our lab. I will show you a video. In the first video, you can see 3 of our works. The first one is using the Taban social robot for education of children with dyslexia. The second one is introducing the Oppo robot. And the third one is using the Rasa social robot for teaching Iranian Sign Language to children with hearing problems.
مثلا میدونید خود تعجب چند بخشه؟ آفرین به شما 3 بخشه. راست میگی؟ آره اشتباه گفتم.
Rasa is a social robot designed and developed in Sharif University to facilitate teaching ISL to deaf children. Having 32 degrees of freedom, including 7 in its active fingers, enables Rasa to interact with users using ISL. To teach a new sign to Rasa, the teacher needs to wear the data glove and perform the sign to pass the corresponding word to the robot. The pre-trained neural network converts the sign to an embedded vector. We have implemented a learning from demonstration structure for teaching new ISL signs to Rasa. This LFD architecture utilizes one-shot learning technique and convolutional neural network to learn to recognize and imitate a sign after seeing its demonstration just once. The expansibility and promising results of the one-shot learning from demonstration technique in this study are the main achievements of conducting such machine learning algorithms in social HRI. Rasa Captures uses hand gestures with a data collection glove. The glove transmits positional and rotational data of the hand and the fingers to Rasa using multiple IMU sensors. Then the data are collected, pre-processed, and finally transmitted to the recognition module. and a state image approach was implemented to convert these data into pictures that can be fed to a deep neural network. RASA uses an adaptive teaching architecture to perform ISL teaching to users, having different modules, including robot output generator module. This architecture helps RASA to adapt its behavior, including the performance speed, the emotional reaction, and the repetition number, based on the user's past history and present performance in a manner similar to a human teacher.
And the next and last video is about using virtual reality games for education of children and also the entertainment. I would like to talk about and play a video about virtual social toys with the aim of bringing inanimate dolls to life. And that's it. Thank you very much for your attention. In case you have any questions, I would be glad to answer. And also you can send me an email.
Professor Tahari, this is a wonderful work. I feel that from visualization point of view, the robots provide a mobile platform to carry that visualization to wherever they go, and then merging with virtual reality. This is a fantastic topic for you, for us. And I wanted to ask you a question, obviously, just a brief one, because we do not know how the connections are going to go for you because you're joining us from Iran. One of the questions I had was that do you expect the robots to be delegated responsibility on our behalf in the future so that they can execute the boring stuff for us and we can concentrate on the fun stuff ourselves? So,
thank you, Professor Senval, for your note and your question. It's actually a difficult question to be answered. On my side, I think we are very far from this point, but there's a proverb that if you can imagine something, you can do it. So we can expect that in the very far future from today, we can reach this goal, but actually and honestly, right now, we are very, very far from it.
Thank you so much. I'm going to move on to our next speaker,
Thank you
Dr.
very much.
Please hang around, and we will be, I'm sure, having some questions for you at the tail end of the question answer session. So our next speaker is kind of representing Symmetrix, and one of our speaker had to bow out because of some reasons, some constraints which came for Dr. Carlos Araujo. He's the chairman of the Symmetrix company, and that Symmetrix company has 300 US patents and more than 300 international patents. We have two other presenters, Haynes Oliveira, who's going to be presenting some of the work which Symmetrix has been pursuing for last several years. And then also that will be followed by another presentation by Symmetrix. So let me talk about Haynes Oliveira, who received his MS from University of Colorado Springs, and works as a research software engineer at Symmetric Corporation and LG Metric, investigating new encoding mechanisms for images, compression, and blockchain. Initially involved with game and web development in Brazil, Haynes progressed in the last 5 years to focus on the research side of systems and information representation. Haynes, would you be presenting next? Go ahead, please.
Thank you, Dr. Samuel. Let me share my screen. So can you see the presentation?
Yes, we can.
Okay. First of all, thank you for the opportunity. It's a great venue to present, and I'm happy to be here with you and David, my colleague, that is going to present next. Maybe confusing to see Algeometric, but Algeometric is a sister company from Symmetrix, and it's a spin-off that originated in Symmetrix, but is using the same knowledge and ideas given by Dr. Carlos. And we try to keep on his ideas and try to bring it to life. So we're talking about homomorphic image processing. We're going to explain this term homomorphic, but it's a very interesting work, and that I started with David. I started using geometric algebra for images and trying to see some properties, while David was doing geometric algebra and p-adic numbers, also called Hansel codes, in another thing. And then we worked together for this experiment, and I would like to share with you guys. So what is the motivation behind our work? So today, you see that every application in your cell phone, in your computer, everything is using virtualized services. Why is that? Well, it's more affordable for the company to be in the market and compete if they can have expertise and computational power from these places. That is way more affordable than keeping a huge team and collocation in your company. For instance, from time to time, you receive emails from your utility companies or a credit bureau, someone saying that they lost your data. So keeping a team to take care of this is very hard and very expensive. So it's better to use the expertise from someone else and to allocate some computational power and then pay less for that, okay? But that comes with a cost. That is basically you store your data in a third-party place, and you're basically sharing ownership. Not every data that is shared is encrypted, so that's a risk. So the way we're going to explain this is basically explaining our tools, the mechanism behind the transformation of the images. We show a use case for the cloud and a beta experiment that we did at company. So we wrap it up with general features and a conclusion on what we talked about. Also, I would just show a resource that was a paper that was the result of our experience, so that you can take a look into all the formulas, ideas, and even a code. So what tools we were using? Okay, basically, we were based our ideas in mathematical resources. We were using Hansel codes, also known as p-adic numbers, to do the security and also geometric algebra. What they have to offer is basically Hansel codes will give the security, we mean the hard problem for our cryptographic scheme, and the geometric algebra will give many operations and will give performance. So why we talk about hard problem? Because when you talk about cryptography, is your cryptography, your scheme is as secure as your hard problem. Okay, so we found a good hard problem in Hansel codes, and we combined with geometric algebra. So that is basically the base for our homomorphic scheme, right? Why is homomorphic? Because let's make it very simple. Homomorphism is a property that you can find some geometric, in some algebra structures. And when you use functions that are homomorphic, you can perform operations with encrypted data, right? So instead of decrypting to perform something and then encrypt again, you do that with encrypted data, okay? So that will be the base for the image processing part. And then from that, you can build an application, for instance, using libraries and functions that implement those things. That is basically the base also for other applications like videos and streaming. So what is the mechanism? Basically, we see the image as a matrix of many pixels, right? So these values are organized in a way that you can see as a matrix. And we want to look into individual pixels, in this case, RGB images. And then we want to transform those pixels into multivectors. Think about multivectors as slots that you can put things inside, like arrays, and then you can make transformations with that, all right? So we can have functions that use, that generate a multivector for each pixel, and that will generate an image of the same proportion of the original image. But of course, it's going to be bigger because every multivector is encrypted. So the size is going to grow, but you can perform on top of that. And that will be the base for generating the encrypted images. So the multivectors, the slots there, we receive the Hansel codes, and then we're going to compute on top of that. This is basically what is used for video too, but we are doing it simpler to make it, to understand the concept and then improve. So a use case would be, imagine a user, this user can be your company, can be me. We are using our phones and everything. We're sharing our pictures or storing our pictures somewhere. And we can have the behavior that we call honest but curious. That is a company that will not harm you, but they will take information from your data and use that as marketing, for instance. So let's say that a program can implement those functions that we just talked about, and then this person can generate a key. That person wants to store a picture into the cloud. To do that, he's gonna encrypt the picture first and then send to the cloud. Then the cloud should have also a same program running there, so it's possible to make the transformation. But the user wants to improve the brightness, okay? So in order to do so, he needs to send a command to the cloud, and the cloud can do the operation because you're paying for the computation, right? So why not use it? So you're gonna receive the result, and then you can decrypt. And that's the idea. So a beta experiment that we did was basically combining some images, using some images to encrypt, make operations, and then see the result. So some of the filters that we used were basically common filters that you see everywhere in Photoshop and other programs, even in your iPhone. So we started to do some contrast, brightness, decreasing, increasing, blending images, in this case, 50% of the pixel, and making masks like covering areas. Like this is very interesting for surveillance. So some of the numbers, to be very practical, was less than 1 second to increase brightness, to put a mask or covering some areas. This is just a rough idea so that you can compare. So general features for that is the use of the computational capabilities of the third party. So you can use that, but you still have some security. Efficient computations through geometric algebra and not just using matrices. and security based on Hansel codes. That's the basic idea. So to conclude, we have many mathematical tools that are not exactly used in these areas. And we're trying to mix it and try to find use for that in cryptography, in image processing. So we developed a scheme that can allow computation over encrypted images. And our initial analysis shows that that is ready or can be used for real world applications. These are basically the features of such idea. So some resources that you can look for is the paper that we published some time ago, and you can see all the details, the formulas in a source code that you can use. So thank you, and I appreciate the opportunity.
Heinz, thank you for your fantastic presentation and giving us some insight behind the scenes, what is going on in this wonderful work. Our next speaker is David. David Williams Silva is a senior research scientist at Symmetrix Corporation and LG Metric, and is responsible for the research and development of innovative products related to security, privacy, and efficient computation powered by applied mathematics. David started his career as a software engineer focused on web services and agile software development, which led him to be involved with several projects from startups to government and large corporations. After 17 years of conducting R&D in Brazil, David moved to the US to engage in scientific research applied to global industry of security and privacy. Go ahead, David, and take it away.
Thank you very much. It's a pleasure to be here today. I'm going to talk about something related to what Heinz Oliveira just presented. It is a more fundamental layer since Heinz talked about a very interesting application with images. And what I'm going to talk about is a project within Symmetrix Corporation, in particular, the Algemetric branch that deals with software. And it's with respect to something called CoAD technology. So it's computation over encrypted data. I'm going to talk about industry problems and related opportunities, and I'm going to show a use case for CoAD technologies. I'm going to show a project that briefly introduce a product that we are working here at Algemetric, usage in the real world, and then present some conclusions. So what is computation on encrypted data? It's a powerful approach to meaningful data process in a secure and privacy-preserving way. So data can be anything. It can be images, like Heinz just showed, can be, signals, it can be frequencies, it can be anything, literally. So here, the idea of computation encrypted data is related to another concept, which is a little bit broader, which is privacy-enhancing technologies. So this is all for the sake of introducing some lingo and some acronyms. So within computation on encrypted data technologies, we have something called multi-party computation, referred to as MPC, fully homomorphic encryption, FAG, zero-knowledge proofs, ZKP, but also some statistical techniques such as differential privacy, synthetic data generation, federated machine learning. So today I'm going to talk more about CoAD technologies, but within the scope of privacy-enhancing technologies for sure. All CoAD technologies have the same goal, which is provide meaningful answers while working with encrypted data. So if we take a look at homomorphic encryption, which is the subject of that Heinz just presented, I'm going to give like a very overall description of this technology. Imagine that you have a data user and he has a database. Everything that he produces goes into this database. And then he can have, as a data owner, he can have access to it at any time. But what if some other people other than him, some other people are interested in getting some insights from this data? Let's say that this data is valuable. So they want to compute some information on that, get some answers, get some insights, get some data analytics. Well, it would be a problem if everyone can take a look at this information. So this generated a privacy issue. So one way of doing this is to encrypt all the data that the user has, and then provide an encrypted version of that data that no one can see anything, but it still can be computed on. So this is what homomorphic encryption and other flavors of CoAD can do. So this phenomenon allows to produce some content while the data is still encrypted, then decrypt that content and give the result back either to the user or to anybody else that is interested in that. But no one is going to see the inputs, only the outputs. And the outputs are generally some aggregated data or some data in a form that will never disclose personally identifiable information. So this is the process that has been called for many years as delegation or outsourcing. So data processing without plain text data access. So you can actually process data without seeing the inputs, without seeing anything other than the output. So delegation via homomorphic encryption is the reconciliation of data availability and data privacy. So this allows a series of applications, but must satisfy correctness, compactness, and circuit privacy. In other words, the functions that are being executed cannot be disclosed. And delegation of all functions for an unlimited number of times is called as fully homomorphic encryption, but there are other types as well when delegation of functions of an arbitrary number of times. This is called typically as leveled FHE. And whenever you can do only a limited number of functions, this is called somewhat homomorphic encryption. However, homomorphic encryption is just one flavor of CoAD. There are many other possible configurations of CoAD, but a more important concept is collaboration. Collaboration is the big word of CoAD, and I'm going to talk a little bit about this today because it's relevant and more comprehensive than just delegation. And some people are calling now CoAD as collaboration enabling technologies. So what are the problems? So we are seeing everyday problems related to malware, to ransomware attacks. We are seeing problems with data breaches, privacy violations. This is happening all the time. All the headlines are showing week after week that regulations are getting more strict, and some organizations are paying large fines due to data breaches and privacy violations. So this is not a problem that we should be overlooking. So let me show how CoAD technologies can address this issue. Imagine that you have a situation where there is an organization acquiring information, inputting in a database, and wants to allow people to take a look at this data. There is a real risk here where sensitive data can be exposed and some violations of even the business and privacy laws can occur as well. However, you have data storage. In order to be useful, it must be stored in a way that can be efficiently assessed and serve a variety of purposes. But then we have the issue of data breaches, ransomware attacks, and sensitive data being exposed. People want to do data analysis, which is once data is at rest and compute some useful information, and according to a large number of statistical and analytical tools. However, then we have the risk of violation of privacy laws again and unauthorized inside access to sensitive information. Finally, data report is something very important in the business, but we have once again the issue and the risk of sensitive data being exposed. So we have now a privacy law called GDPR, with General Data Protection Regulation. And if we decide to do this using the company's infrastructure, a database that contains sensitive information, we are now in the risk of exposing sensitive data as soon as we decide to transport that data. And then if we decide to give third-party access to that data, then we are also violating GDPR requirements. And if we decide to do any report on that, we are further expanding this violation. So enter Obscura, which is a solution from Margeometric. And this is an overview of the solution. We have a protected database where all the data is encrypted. And we only transport encrypted data at all times, so no one can see anything. But it's still, we can run algorithms and perform a series of reports and then visualize in the end, after decryption, very important data such as business intelligence, data that gives insights and strategic data for organizations and decision makers. And just to show how this works, we have a component called Obscura Data Sync that is deployed inside the customer's infrastructure and then encrypts that data using one of the flavors of co-ed technologies. Here, we have a series of computers or servers from 1 to n. It can be any number. And if we have just one, it will be typically fully homomorphic encryption. But if you have multiple servers computing this data, it will be probably a multi-party computation setting. In this next slide is more complete the view where we show that the data sync is inside the customer infrastructure under the customer control. And then we have this environment called secure computation environment where communicates with an API and then provides the dashboard with useful information. So this is being used in the real world. We have 2 companies in Iceland, a debt collection company and a performance marketing company using Obscura right now. So conclusions, homomorphic encryption is one of the many flavors of co-ed technology enables secure and privacy-preserved collaboration between multiple parties. There are plenty of opportunities in the industry for co-ed technology, all very challenging as well, rewarding. Obscura is powered by co-ed technologies such as MPC and FHE, and is being used in the real world for enabling collaborations that would not be possible without risks and penalties, if not through co-ed-like solutions. This is a field that is rapidly growing with plenty of room for innovations. If you want to hear more about this, if you're curious or want to see a demo, please contact me. Thank you very much.
David, this is a wonderful presentation, and I know that visualization efforts with security intact, they will explode the market further. So thank you very much for presenting. We're going to move on to our next speaker. Our next speaker panelist is Dr. Hector Perez Gonzalez. Dr. Gonzalez is a full-time research professor at the Engineering School, Universidad Autónoma de San Luis Potosí in Mexico. Dr. Perez Gonzalez was a 2014 Lee Kimchi McGrath Worldwide Fellowship recipient from the International Association of Science and Technology Centers. He's the manager of the Interactive Museum of Applied Technology, IMAT, project of FI-UA-SLLP. Dr. Gonzalez led the creation group of the New Intelligence Systems Engineering Academic Program at UASLLP and directs the Computing Engineering Program, ranked #1 in the country by the Mexican National Evaluation Center. Dr. Go ahead, please, Hector. Go ahead, please. Dr. Gonzalez is next.
Hello, thank you very much. Thank you for the invitation, Dr. Samuel. I am going to talk about a proposal to visualize a new form to visualize the performance of a group working in a homework. So with these pandemic situations, the homework were made in different form, just by teams, not Microsoft Teams, the real teams, the original teams, but in home, so at home. So let me show you a 6 minutes video, and I'll be back to work with the real tool. Let me see, okay. Hello, I am Hector Perez Gonzalez, and I am going to talk about Dynamic Chat Visualizer, analyzing people working on a group project. Many computer programming courses treat a finished program as the only artifact that the students must deliver. This can lead to the false belief that the most important thing is the product and not the process that must be followed to obtain that product. To evaluate the performance of the team and each of its members, we created ChatVis. This tool allows us to visualize individual and team behavior in terms of participation, leadership, and organizational skills, among others. We propose the use of a social network, like, for example, WhatsApp, as the only communication platform among members of a homework software development team. The output of this application is the input for our tool. Before explaining the basic operation, assumptions, and elements of ChatVis, let's see it running so that we all know where our explanation is going. To arouse our interest, let's see it working with information from a large group of people participating in a chat for several months. Let's see it first without further explanation. This representation comes from a group of pediatricians maintaining communication to organize the diagnosis of infections and the application of antibiotics. Okay, now, let's start from the beginning. Let's think about a hypothetical small group using a social network. To make this more interesting, let's think of a brilliant group of people. Let's say James Gosling, Guido van Rossum, Larry Wall, and Anders Hetsberg. During this conversation, 26 messages were exchanged. Let us view the first messages, including the startup message sent by the WhatsApp system. Chatbis considers a message only when it has been answered. So the assumption is that every message is answered by the following message. This is not necessarily true in a real conversation. The first messages were sent just by Carol, Larry, and James. Let's see how this happened. One message was sent by the system. One message was sent by Larry. Two messages were sent by James. And two messages were sent by Carol. In this way, our model showed the percentage of messages sent with respect to the total number of members of the group. For the case of a common conversation, this information may not be very useful, but for the analysis of teamwork, it certainly is, as we will see later. This is part of the first section of the Chatbis model based on previous work by Nadi Bremer. Nadi's original work is based on the concept of chord diagram. A chord diagram is a graphical method of showing interrelationships between data radially around a circle. It represents flows or connections between various entities which are called nodes. Relationships between nodes are drawn as arcs connecting nodes. The size of each arc is proportional to the importance of the relationship. Now, let's visualize the interaction between group members. We can obtain interesting information if we know the interaction between each pair of members of a group. Here, we can observe this interaction between pairs. With this model, we can see the tendencies of each member to answer more messages from some members and less from others, or in the opposite direction, knowing which member responds to messages from a particular member. In our tool, at the end of the animation, you can put the cursor over each interaction area or chord to get information about the described pair interaction. During this conversation, 26 messages were exchanged. Let us view the complete messages story. Now, let's see how we can analyze the work of a group of students in a programming task. For this work, we must ask students that when doing homework, the only means of communication is WhatsApp. The bottom section of Chatbis consists of a timeline that dynamically displays the behavior of the entire group. With this, we can appreciate, among other things, the degree of procrastination of the group in the search for its objective. Just imagine the things you can do with this. Thank you for your attention. Well, this is the presentation. And now let's see the tool, the real tool in life. we will start. We're going to start with the 26th dialogue of the presentation. As you can see, this is the 5 people sending messages, and the messages were sent just in one day. So this bar is just for the January 2nd, 2022. Let's use the tool with other example. Let's see, with the homework, it's about 20 people, about 200 messages. But this is, in this case, we have 5 days for the homework, 6 days. We can see that the 4th day was very busy there were 130 messages. And the third example will be the big one, about the physicians, the pediatricians. As we can see in the bottom sections, we can see the complete history per day. This day was very busy, this one also. You can see the messages here in the upper right corner. So this is the tool, this is the proposal, and we are working now in kind of a semantic second version, not just bars of the same color. Every bar will have different colors depending on the semantic of the message. The homework we have here is about, not in this one, the pediatrician's note. Let's see the last one, the other homework. We have another homework here. 2 days to do that, 6 people. And this is the messages they sent. I say you can do you can use the only tool you can use to communicate is WhatsApp, not telephone, no message, no Discord, not every other tool, just WhatsApp. So we have all the information here, and with this we can see, for example, that this person communicate with this person, for example, let's see here, 1 message to Aaron and 0 message. Oh, this is the same name. We can give, for example, Julio send 1 message.
Hector, I think I would like to wrap up the session right now, if that's okay with you. There's one more speaker to go.
Okay, yes. Okay, that's the end of the presentation. So I am open for questions at the end. Thank you very much.
Professor Gonzalez, there is a question on the chat for you after the next presentation. There's a question and answer. So I'll get back to you. We are saving some time for questions and answers. This is the time. If you have any questions among the audiences, please type them in and we'll try to get them as much as we can. I'm going to move on to our next presenter, Dr. Terry Jensen. TJ is a career computer scientist and information technologist with offices in DC, Honolulu, and Colorado Springs. He is a fluent programmer and has developed a large library of software prototypes for demonstrating advanced technology, doing AI and machine learning. He's working with quantum hardware-based laboratories and quantum computer as a service, QCAS providers. His employers over his careers have included Lockheed Martin and DOE Argonne National Lab. TJ, go ahead, please.
Well, thank you. I'm going to talk about visualizing the invisible. That is the world of quantum physics and quantum mechanics. Now, you may all recall that back in 1927 in Belgium, there was the great gathering of all the world's foremost quantum, or actually at that point, physicists who were studying the quantum phenomenon. And you see Einstein in the middle here. And over here, I'm going to point out Niels Bohr. Niels Bohr was in an argument with Einstein, and he won the argument, which was a little bit humiliating for Albert Einstein. But Einstein came to understand that this phenomenon is real, and this resulted in the Copenhagen interpretation from this conference, which we don't have time for physics here, but we're going to talk about the significance. But Niels Bohr made a very interesting statement soon after this conference. He said, "We must be clear that when it comes to atoms, language can be used only as poetry. The poet, too, is not nearly as concerned with describing the facts as with creating images and establishing mental connections." This is the context of which this talk is about. It is about the atomic models in quantum physics and the quantum mechanics there that we cannot see and we cannot describe with words. But the mathematics is very well known, and the mathematics is the most reliable, repeatable of all of physics, making quantum 100% reliable results every single time you do an experiment. Now, given that the language of quantum is at best poetry, how can we augment understanding in other ways? How can we use visualization, for example, to help us understand what we can't describe in words and we can't see? So mathematics is the exact science for quantum, but nobody understands the why it happens the way it does. We have lots of hypotheses, lots of theories, and some of them are very far out, like the multiverse theory that we're not the only universe out there. We have versions of ourselves in almost infinite numbers of other universes. Very hard to get your head around. But the words themselves, conjure up these images. But this is all based upon the mathematics and trying to explain the mathematics. It has no other basis than that. So why this is an ongoing philosophical debate and has many competing theories, but the one that's really ruled out and taken almost all physicists is the one for multiverses. Now, mathematics uses complex imaginary numbers. And these imaginary numbers are not part of our reality, as you know. And this is pretty much the driving force for the multiverse theory, that we're not the only universe. Now, another thing we need to be aware of is that there's a gap between the various professional communities, in between quantum physics, quantum mechanics, quantum computing, quantum networking, quantum sensors, electrodynamics, and of course, a gap between the use cases. I work in the defense and intelligence world, so our use cases are foreign language to quantum physicists and vice versa. The mission managers don't really understand anything about what the quantum scientists are talking about. And we need ways of communicating better. So we've developed this quantum meta-science to help improve comprehensibility, understanding, and the science itself, because we're in a great race in quantum right now, and we need to win that race. And so we need to become better at our quantum physics. And we have a number of ways to do that. Now, is visualization the solution or a solution? And the answer is, well, partially yes. And now that's not the only part. Of course, the ontologies and many other aspects, new tools, new approaches are all part of this discussion and beyond the scope of this talk here. But visualization does play a role, and I hope to convey that and engage with you in discussion toward the end on what that role is. I'm going to propose 10 ways visualization can help quantum and vice versa. Quantum help visualization. Those are, number one, visual programming of a quantum computer. For us to program in the native quantum mechanics language would be next to impossible for the human mind to do effectively. So we use visual programming, we use pictures, and we drag and drop things on the pictures with classical programming languages like Python and Julia. And those then create the instruction sets, which are quantum mechanics instructions. And then that goes in and controls lasers and other things, magnets, to control the atomic spins and other things within qubits within this quantum computer. The second area I'm going to talk about for visualization is quantum physics, and especially visualizing quantum superposition and entanglement. These are very hard to understand with simply just words. And we're going to have a little fun here in a few minutes in seeing this with an animated real-time collection from data from photons that are entangled. And we're going to see visualized mathematical renderings of what's going on there. And the third way is an area you'll definitely relate to, and that is the rendering of sensors. In this case, I'm going to use the example of rendering quantum sensors, maybe 100 of them, into visualizing models of the human brain at a very, very detailed level, much beyond what we can do today with classical sensing, and actually see pinpoint almost at the neural level down to areas of the brain for both research and for treating diseases like Parkinson's, where you can place an electrode in the brain precisely within a very, very fine neural cluster if you use the quantum sensing approach versus classical, which is very crude. And these are the other areas. I'm not going to talk about them today. We can get back to them later if we want to after this main talk. Now, here is a rendering of a visual interface for a quantum. I'm going to go back to that. A programming quantum computer. This is the quiz kit for the IBM quantum computer. It's a computer that uses superconducting qubits at almost absolute zero temperature. And you drag and drop things on the graphical image. For example, if we're going to entangle particles, like we're going to see in the video in the next type, is you would simply drag your instructions onto this qubit diagram and then execute it, and that would do things. For example, entangle two particles. Now, I'm not going to talk about the details here. If you want to see the details, I got lots of references for you. I handpicked someone I could send to you if you want to give me your email address at the end by emailing me. This is only one of the quantum computers and one of the visual interfaces. There's also the Rigetti quantum computer, the IonQ, Alibaba quantum computer, the Google quantum computer, and some others. This is the second type of visualization for quantum I'm going to talk about. This is the quantum physics. And here we see a particle rendered as a sphere. Now, this is in superposition in a quantum computer qubit, meaning that it's in many positions at the same time. And that, again, is very hard to get your head around. I hope that this video and this talk today will help you understand that a bit more visually and help you see how visualization does so much for helping us comprehend what words just can't do justice to. So looking deeper at this, you can see here that we have a particle or a photon, and that the spin can go, as you see on the first one, the arrow to the right, and then the one on the left, you can see the arrow pointing to the left, spinning at the left. Now, in superposition, these can be spinning both directions at the same time. Again, very hard to get your head around with words and understanding. Superposition collapses into a state when you observe it. If we observe this, we'll either get a spin up, in which it's pointing up, or a spin down, pointing down. Now, when we entangle particles or photons, we know that those entangled particles, which have been split apart, because you can't copy a photon or particle, you can only split it into two parts. We know that the two parts energy must be equal to zero, so one will be spinning up and one will be spinning down. If we collapse one and we find it spinning up, we know instantly with 100% confidence that the other one is spinning down. And so this can be the other side of the galaxy, instantaneous collapse, and instantaneously know, regardless of how far they are apart, the value of the other one. This is used today in securing communications. We have networks now with satellites in China that secure communications by entangling photons and then sending it from satellite down to ground stations 3,000 miles apart. Now we're gonna have some fun. We're gonna have a little video here. So for the next 2 minutes, we're going to watch this, and I'll get back to you with an explanation of what's going on. Thank you, TJ. I appreciate the presentation. There are some questions which are on the chat box. I'm going to address them next. Okay.
So I think one of the things which I wanted to bring, these are our 5 presentations today on diversity of ideas. We have brought a variety of ideas to you. There is a question for the panel. I'm going to get right to that. That is basically related to, for data visualization, what is one thing that practitioners can do to improve the state of the things, and maybe more relevant for all of you panelists is what has worked well for you. So I'd like to get started with Ali Reza. If Ali Reza is here, we want to know, while you were working, what has worked well for you, Ali Reza. Go ahead, please, if you're still here.
Hi, Professor Senval. Thank you very much for handling the panel. Let's start with the others. I will say my answers at the end.
Okay, great. So I think whoever wants to chime in, maybe Hector, go ahead. WhatsApp application, that was fantastic as a kind of a social interaction measurement tool. What has worked well for you?
Excuse me, I had a little problem. Would you like to me answer the question in the chat?
Sure, you can do that.
Okay.
Anybody else?
No, please, sorry, we're broadcasting live, please answer the question live so that the participants on the live stream, as well as participants in the room, can hear what you have to say. Thanks.
Okay, and I think if we can also take away the presentation, that way all of us can come on the main chat. So one of the questions which has come up really is, and that's actually a good one, what has worked well for you and what visualization community can take from this presentations which we have had. Particularly, TJ, go ahead and answer that question if you have any thoughts around quantum computing. What has worked well for you? What are you seeing in the industry? And what we can take away as a visualization community?
The quantum computing is a little far out. We have laboratory results where we can do quantum computer programs and program these qubits with quantum mechanics instructions. But we don't expect to be able to use these quantum computers until 2035, or maybe a little bit sooner if we're successful at, increasing the reliability, meaning that the error count is down and the numbers of qubits in these quantum computers is up. We need thousands or tens of thousands or even millions of qubits to do interesting things today, because we can't use all of them because of noise. So it's a little premature to talk about useful applications yet. What we can say that we're getting very interesting results. We're seeing things at a faster clip of progress than we expected, but cannot report any major success stories in terms of large-scale quantum computing deployment yet. Does that answer the question?
I think somewhat answers the question. I'm going to continue. Yeah, absolutely. In the quantum computing world, that it is some changes which are going to be coming pretty, slowly, and somehow that will have a major impact on the visualization tools in the future also. I think one relevant presentation which were there was Haynes and David. Of course, the security applications are absolutely necessary for managing medical records and other things. So go ahead, Haynes and David, if you're still here, to talk about what have you seen in the industry which has worked well for you, and share that with us in the visualization community. Go ahead, please.
Yeah, so one interesting thought on this is that I showed today very briefly secure computation of data, so extracting meaning from data, but that's the foundation of executing any algorithm, really. So you can think of my presentation as the foundation for the particular work that Haynes demonstrated today, which is image processing. So now let me give you some actual examples. So imagine IoT applications, smart cities applications, or something like healthcare that is very sensitive, like information, images that cannot be disclosed to the public, or even surveillance, or even military or law enforcement. So all of that would be very difficult to process without privacy concerns, right? So imagine that you encrypt everything and then you can do image processing on all of that. That's remarkable. So this is one of the enabling capabilities of this kind of technology that we discussed.
Thank you so much. I know Hector has come back. Go ahead, Hector, and answer that question. What has worked well for you? There's a multi-part question, diversity and inclusivity. We're going to go to that next. Go ahead, Hector.
Thank you. Yes, I have had a good results. Good results in education, because when you are a teacher and you assign a homework, you don't have control about the participations when the team is working at home. So with this, the question which part of the assignment make every one of the members of the team is not very easy to obtain. About the state of the thing now is that we have good results, but in our second version, we were going to try to discern, to identify what happened when some people are not participating a lot. Is that the question? Is that because they don't want to work, or probably they are, for example, a person who is not allowed to participate because he is or she is not in the social group. So this is very important, because we can try to find this kind of conflicts before among the members that is not possible to discern, to obtain, if you don't have this kind of tool.
I think, Hector, that you actually put the right context to that, is that we do not know sometimes what people are participating and what the reason behind it. And that inclusivity answer could be perhaps wrapped into there for sure. When we started the Diversity of Idea panel discussions, we were going to bring multiple, of course, we did bring multiple scientific work right now, a body of work which is very mature from social robotics and everything else. The diversity and inclusivity is something which is going to be building on top of it. I see Ali Reza is back. Go ahead, Ali Reza, and answer that question from your perspective from Iran.
Thank you very much, Professor Sembol. On my side, as a teacher, visualization is very, very important everywhere. But in social robotics, if I can share my screen for a while, for a quick second, I can show you that in one of our work, we visualize a performance of some children with autism as a picture. And with a quick look at the picture, you can see how much the participant perform well in the imitation task. For example, here on the left image, almost all of the picture are yellow, and it means that the child performed very, very well. But here on the other side, another child performed not good. And this is just a visualization of a whole performance and show it as a picture. So I think this is one of its application for our work.
Thank you very much. Haynes, you have been quiet. Do you have some last minute comments on this particular topic? I do want to say that the diversity and inclusion remains something which is moving forward. I was at the Digital Humanities panel yesterday, and they were exactly talking about diversity and inclusion. They're also particularly thinking about interdisciplinary work, which is there in this area, by bringing 4 or 5 different topics: social robotics, quantum computing, the visualization on internet, and security. I hope we have started the conversation in that direction. I'm going to invite any other panelists who wants to chime in about this particular question. Diversity and inclusivity are very complex. For data visualization, what is one thing that practitioners can do to improve the state of the things? What has worked well for you? I think my answer to that as a moderator here and the organizer of this particular Diversity of Idea panel today, my answer to that is collaborative and also interdisciplinary, highly multidisciplinary, highly a system which is a very much collaborative, will bring in some of those results into us. So David, I invited you earlier. Do you have any final comments and thoughts before we end? We are already going 1 minute over, so go ahead, please. David, are you here? I'm sorry,
Yeah.
James also, anybody else? I would like all the panelists to come in. Anna and also Chris, if you're monitoring us, is there a question which we need to answer, panelists? Otherwise, we'll expect emails from all of you. Go ahead, Chris and Anna, if you have any last minute questions from your vantage point for us.
So pretty quick, just a comment on what you said. So my previous comment was actually addressing this. What can be improved in the state of things is that imagine that you have these awesome algorithms today that do computer vision, that do image processing, that do all sorts of filtering and effects and so on and so forth, animations. So adding a security and privacy layer to that allows the outsourcing of these computations whenever computation is very expensive. So think about rendering, like a very complex animations of long scenes. This could be done by third parties, but how can we do that without exposing too much or violating privacy or sensitive information? So techniques like co-ed techniques can help to improve the state of things and allow collaboration, like you said, Dr. Semo, without the fear of exposing information that should not be exposed.
Thank you. Haynes, you get the last comment on this panel. Go ahead, please.
Thank you. I think that Professor Tahiri work was showing a very important inclusion and diversity use of the technologies and recognizing patterns and finding ways to see through the eyes of others. So I think it's an amazing job. And this is a very common thing now in many disciplines, trying to find patterns. For instance, in compression, we try to find patterns and to see how to reduce that. But in this case, to help others. So I think it's an amazing use of the technology.
Well, I'm informed by Anna and Chris. Thank you, Haynes, for answering that question also. I'm informed by Anna and Chris that there are no questions from the audience. This was the first panel. There are 3 more panels today. Please come back and join as an audience if you like our work. We are going to sign off. Thank you from the panel, Diversity for Ideas. I'm going to throw it back to Anna just for the last minute. Any comments or questions she might have? Otherwise, this is a wrap up. See you next year. Thank you.
Thank you, everybody.
Thank you. Bye.
Thank you.
Bye-bye.
Enjoy your break, and thank you once again to the panelists. We'll be back in about a half an hour on the Visualization Meets Accessibility panel. We look forward to seeing you there. Thanks.
Bye.
Thank you.
Goodbye.
Thank you, TJ. Bye-bye.